Hello everyone, welcome to the new session on JA Welder. So in today's session, I will be discussing 25 questions in connection with the JA Welder. So here is our first question. Which flame is suitable for welding ferrous metal, copper and aluminum alloys? So there are four options: oxidizing flame, carburizing flame, neutral flame and none of the above. So mainly there are three types of flame that we are using for the gas welding: oxidizing, carburizing and neutral flame. Based on our requirement, suppose we want to weld the hard metal, we will be using carburizing flame, and if we are welding soft metal, we will be using oxidizing flame. In normal, we will be using a neutral flame, and for the cutting operation, we will be using the oxidizing flame. So our option is neutral flame. It's a normal metal, ferrous metal, copper, and those all comes in normal metal. So we'll be using neutral flame for the welding. Here's the next question: which flame is suitable for cutting operation? That I have already mentioned. For cutting operation, we will be using excess amount of oxygen. After we are heating the metal, we will be cutting the metal with the help of an extra oxygen. So we will be using oxidizing flame for the cutting operation. So the answer is oxidizing flame. Our next question: which flame is suitable for welding non-ferrous metal, such as brass and bronze? I have already mentioned brass and bronze. They are comparatively soft metals. So for soft metal, again, we will be using oxidizing flame. For hard metal, we will be using carburizing flame. For normal metal, we will be using neutral flame. So our option is oxidizing flame for the welding of brass and bronze. So our next question: which flame is suitable for welding steel? Welding steel. So again, it comes under the hard metal. So we will be using carburizing flame for the welding of steel. Which of the following is not true for gas welding operation? So it's a very tricky question. Our options are: heat effective zone and distortion area less compared to arc welding. It is suitable for thin sheets. It is lower than arc welding. There are safety problems in storing and handling the gas. So our question is not true. So not true means it means all are true about gas welding, but the first option is the correct answer. Heat affected zone and the distortion area are less compared to arc welding. That is the wrong answer. Heat affected zone and distortion area are less compared to arc welding is the wrong answer. What is the temperature of an arc in case of an arc welding? So very high temperature is generated. Actually, the current is traveling through the air. So very high temperature is generated in arc welding. It is around 3600 degrees Celsius. It is the temperature generated in an arc welding process. In an arc welding, the arc initiation voltage is in the order of. So in arc welding, arc initiation voltage will be very lower value. So it is in the range of 60 to 100 volts. So even we are applying the normal voltage, it will be stepped down using a step down transformer. A gap of dash is maintained for producing a sound weld. So a sound weld means that's a very good weld. For a good weld, we should maintain a gap of 3 mm. That is a very good apt gap for obtaining a very good root penetration. Which of the following welding process is non-consumable weld? It's a very simple question. So all of you know that gas tungsten arc welding, that's the TIG welding, we are using the non-consumable weld. In all other processes, we will be using the consumable weld. And the main confusion between MIG and TIG welding. MIG means metal inert gas welding. TIG means tungsten inert gas welding. In MIG welding, we will be using a consumable electrode. In TIG welding, we are using a non-consumable electrode. Okay. So next question: in arc welding, key elements to be controlled to obtain satisfactory welding operations are. So the three elements that we are controlling to obtain or for a satisfactory welding operations are current, voltage, speed of travel, current, voltage, arc length, current, arc length, speed of travel, current, arc length, and speed of travel. So actually, it is the first option. So we are controlling the current and voltage. If you have seen the welding operation in industrial area, they will be using a current controlling device with them for obtaining a better root penetration. So for industrial area, there they have to undergo the welding inspection after the first root pass. So proper current and voltage is required for a good root penetration without any burning out like that. Okay. And the speed of travel is also very important while we are discussing about the weld deposit, the amount of weld deposited during a welding process. Next question. In gas tungsten arc welding, that is TIG welding, the following polarity is used. So in TIG welding, we will be using all the polarities. First, that is direct current self polarity, that is DCSP, direct current reverse polarity, that is the DCRP, alternating current high frequency, that is the, and all these polarities are used for the TIG welding operation. Heat is created by the chemical reaction. It's a very simple question. Actually, this question is repeated many times in PSC examination. That's a thermic welding. That is by using a chemical reaction. That is iron oxide, aluminum, and iron oxide. We will be using powders to obtain a heat. And that is used for melting the metal, and thus we are producing the welded joint. So in resistance welding, we will be using electricity. Oxy-acetylene welding, we will be using acetylene and oxygen to produce the heat, and tungsten arc welding, we will be using the arc to produce the heat. In thermite welding, we will be using the chemical reaction to produce the heat. The voltage used for resistance welding is generally kept between. So for resistance welding, we need very high current to obtain the weld joint. So we are using very low voltage for resistance welding, that is around 4 to 12 volts we will be using for the resistance welding. The heat generated in resistance welding is expressed by, this is a very simple equation. Actually, it is I squared RT. 2 is I squared. First option is I squared. You have to read it as I squared RT. Second option is IR square T. Third option is IRT square. Fourth option 2 IRT. So actually, the first option is I squared RT. That is the equation for heat generated in a operation. Okay. The voltage needed in the resistance welding does not depend on the voltage needed does not depend on the area, thickness of weld, length of weld, and composition. Actually, the composition, depending on the material, we have to decide the voltage. Depending on the area we have to weld, we have to decide. Depending on the thickness of the metal, we have to decide the voltage. The length of the weld, how much length we have to weld. Suppose even we have to weld for 1 meter, or even if we have to weld for 10 centimeters, we will be using the same voltage and current. The length of the weld will not depend on the voltage. Each of the following statements are true for resistance welding. So we are actually coming to the answer. Actually, sentence number 1, 2, 3 are true for resistance welding. That is, time for which the current flow is very important. After switching off the current, the pressure is maintained until it cools. Water is circulated through hollow electrodes to cool the electrode. So most of them will neglect the third option, that is water circulation and current operating welding operation. That we are not thinking about. Actually, water is circulated through the electrodes to cool the electrode. In resistance welding, 2 electrodes are made up of. They are made up of copper. Actually, in resistance welding, the electrodes are made up of copper. Each of the following is not a resistance welding: spot, butt, pressure, and percussion welding. Actually, the option is pressure welding. Pressure, even we are applying the pressure in a resistance welding, but pressure welding is not a category of resistance welding. Most of us will think that we are applying pressure in resistance. Pressure welding will be treated as a resistance, but pressure welding is another category which will not come under the category. Many of us will go for the option number 4, which is a percussion welding. Actually, it is a part of resistance welding, or it's a type of resistance welding. Resistance welding process suitable for welding ferrous and non-ferrous nickel up to 8 mm thickness. Up to 8 mm thickness, we will be using a spot welding. Up to 8 mm thickness, we will be using a spot welding. In spot welding for lap joint, the diameter of weld zone. Actually, we have to remember some terms in connection with the spot welding. That is the It's option D. 2T plus 2.5 mm is the diameter of the weld zone. Yeah, it should be 2T, where T is the thickness of the sheet. The spot welding space between two spots is given by 12T. The spot welding the tip diameter of the electrode is about. So, this question also repeats a very first time in an MPS exam. So that's equal to root 2 is the answer. Root T is the answer. Which of the following gas mixture is not used in gas junction arc welding? Argon helium, argon nitrogen, argon hydrogen, argon carbon dioxide. Many of you think that argon hydrogen is an explosive gas, so you won't be using that in a TIG welding. So this is the wrong answer. We are going for the argon and nitrogen, which is not combination, which is not used in the TIG welding. Gas metal arc welding, MIG welding, which of the following polarities generally used? We have already discussed in TIG welding what are the polarity we are using. In MIG welding we are using the direct current straight polarity. In TIG welding we are using all the three polarities, but in MIG welding we are using direct current straight polarity. Okay. Which welding process is used to join two thick plates in one single pass? Two thick plates in one single pass. We will be using electrode slag welding. So we can weld very high thickness plates with the help of a electrode slag welding. All other obviously welding mainly will be used for a thin metal. Gas metal arc welding is a normal thickness metal. For electrode slag welding, we can go for a larger thickness plate. Okay, and that's all for today. Today we have discussed 25 questions in connection with the JA welder. And I will be continuing this MCQs in the next session. Thank you.